This video looks at solving formulas for a given variable in light of the quadratic equations unit. So let's say you were given an equation, a formula, and you're asked to solve it for b. So first you want to isolate b and whatever is in its term. So let's subtract the a squared from both sides and subtract the c squared from both sides, leaving us with b squared is equal to d squared minus a squared minus c squared. Now we still want b alone, but it's squared, so we're allowed to square root both sides, and we're left with b equals the square root of d squared minus a squared minus c squared. However, when you release a variable squared with a root, you're left with an absolute value. So that absolute value, by the square root property, allows you to give you the positive or negative version of your answer. So don't forget to include that there. Here's another example. Solve this one for x. X is in the denominator. It's stuck down there. So let's take this and multiply through by 2x squared. Or let's just so x is stuck in the bottom, so let's multiply both sides by x squared so that it can be removed from the bottom. So now we have mx squared equals m1 times m2 over 2. And now we want x by itself, so we need to divide both sides by m. So we then have x squared is equal to m1 m2 over 2m. But again, we need to use the square root property. When we square root both sides, we're going to have the absolute value, which then gives us the positive or negative version of both of these answers. And also we have a root in the denominator, so we need to rationalize the denominator. So notice you have root m1 m2 over root 2m. So we need to multiply by root 2m in order to get rid of the root. So that leaves us with root 2m m1 m2 all over 2m as the answer for x. And here's another two examples. Here we have to solve for r. So remember, whenever you have your variable in two places, it's best to try to usually to factor it out. However, if you factor it out here, it doesn't completely factor out because one of them's squared. So in this case, we might actually need to use the quadratic formula, because you can see that this is in the format of the quadratic formula. So it's like pi r squared plus pi s r minus a equals 0. I've written it this way so we can clearly see the a, b, and c coefficients. So that's a, that's our b, that's our c, and we can use our quadratic formula to find the answers for r. So we've got negative b, which is pi s, plus or minus b squared minus 4ac over 2a. Now we need to simplify this as much as possible. Negative pi s plus or minus. And here we've got pi squared s squared. So pi s squared. And this will be plus 4a pi. 4 pi a. Pi is a number, so it goes before the letter. Over 2 pi. We can't really do much more than that. We could factor out the pi, but it'll still be under a root. So there's our formula. Lovely, isn't it? This last one here, we want to solve for v. Like, look how trapped this v is. We need to release it. So there's a few things to look at here. We've got this thing under a root, and the root is in the denominator. So first off, it'd be nice to release the root in some way. So we could do that by squaring both sides. We're always allowed to do that. So let's just square both sides. So we'll have m squared is equal to m naught squared over this root squared, which then just leaves us with whatever this bracket is. Now, we also have this in the denominator. It'd be nice to get it out. So maybe let's use cross multiplication to release that a little bit. So m0 squared equals m squared times the bracket. And because we want v alone, and it's in this bracket, we should distribute it out so that we can have it on its own. So that's m squared times 1, and then minus m squared v squared over c squared. And we want v by itself. So let's start moving everything over to the other side. So subtract the m squared. m0 squared minus m squared equals negative m squared v squared over c squared. So now this is one whole thing, and we want v by itself. So we need to divide by this other part, which will be the same as multiplying by the reciprocal. So it'll be the same as taking this, what's here, and multiplying it by negative c squared over m squared to give v squared. Now this can be seen as all over. Doesn't really matter there, except, yeah. And then, now since we have this square, again, we want to use the square root property. So it's going to result in v equals the positive or negative square root of whatever all this stuff is. And all this stuff, the best way I can think of writing it at this point is just neatly rewritten like so. So since we have this root here, let's play around with it a little bit. So it'll be plus or minus the root of negative c squared m naught squared minus m squared over m squared rooted, which will be m, and the plus minus is there, so it'll just affect it. That won't make a change there. Now, inside here, you could simplify this. However, if you split it on the negative c squared, if you just root that, it'll be an impossible thing because that'll be a negative positive number, which will be negative. So let's put the negative inside into the bracket. So that gives us root c squared, and I'm going to multiply both of these by negative. So there'll be negative m0 squared, and then this will turn into positive. And here I'm just playing. I mean, if you answered this, that's fine. But let's just see where this goes. So then you'd have plus minus root split on both. So if this root is split on the c squared, that'll be just c. And then we'll have m squared minus m naught squared all over m. So I think this is the cleanest way to write it. The reason why I was being careful here is because you can't take a root of a negative, so I ended up putting the negative inside of the bracket. It still means that if this inside ends up being negative when they evaluate it, then it's an impossible thing.